Hello, so in 7.4 we are looking at inscribed angles. So take note here, an inscribed angle, angles with a vertex on the circle and sides that contain the chords of the circle. So you should have vertex and chords. So here this is saying our vertex is R and we have chords of the circle going out to S and Q. An intercepted arc is an arc with endpoints on the sides of an inscribed circle, so with endpoints on the sides of an inscribed angle, and lies on the interior of the inscribed angle. So the intercepted arc is this part right here, our QS. So note inscribed angles and intercepted arc. So previously we learned about the central angle, and that came out of the center with two radii. So we said that if this angle here was x degrees, then the arc was also x degrees. Now, we're looking and we have a new theorem. So if an angle is inscribed in a circle, then the measure of the angle equals 1/2 of the measure of the intercepted arc. So that's saying here that if this is x degrees, then this is 2x degrees. Or vice versa. If here we have y, if we have y here, then we have 1/2 y here, or y divided by 2. So just 3 different ways that an inscribed angle can look. It can have P on the side, so it goes through P. P can be on the inside of the inscribed angle, or P can be on the outside of the inscribed angle. All right, so let's put it into practice. Let's find the measure of angle B. Here we see that arc AC is 60 degrees, so we're going to take 60 and divide it by 2 to get angle B to be 30 degrees. Here we have that angle RST is 63 degrees, so we're going to take 2 times 63 to give us 126 degrees for the measure of arc RT. All right, so another theorem here. If 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So that's saying that if we have an inscribed angle there, and we also have an inscribed angle here, they both of those inscribed angles share this intercepted arc here. And so that's saying that this inscribed angle is congruent to this inscribed angle. So let's do a few practice. If we want to find the measure of angle T, we see that we have an inscribed angle there and an inscribed angle here. So they share SB. So we can set 3x minus 5 equal to 2x plus 15. Solving, we get x to be 20, and then plugging back in for angle T, we get 3 times 20 minus 5. So we get angle T to be 55 degrees. All right, let's do number 4 now. So now we have that measure S, angle S, so we have that angle right there. And so that is 3x. And then we have that the measure of angle V is x plus 16. So since they share arc TU, we know that S is congruent to V. So we can set 3x equal to x plus 16. So we'll get 2x to be 16. So x is 8. And then from there, we want to know what the measure of angle S is. So we can take 3 times our 8 to give us our 24 degrees. All right, so another theorem, an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So that's saying here we have an inscribed angle and FH is a diameter. So that's saying that angle G is 90 degrees. So if we think about it, all the way around from F to H is a semicircle, so that's 180 degrees. So half of that would be 90. So let's find the measure of angle F. Here we see that we have a semicircle, so angle G is a 90-degree angle. And then from there, we know that the sum of a triangle is 180, so we can set 4x plus 2 plus 9x minus 3, but we already took away 90, so we can set those two equal to 90. Solving, we'll get 13x minus 1 equals 90, 13x equals 91, so we get x to be 7. But we wanted to find the measure of angle F, so we can take 4 times our 7 plus 2 to give us 30 degrees for the measure of angle F. One last theorem. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So this is saying that the measure of angle K plus the measure of angle M, since these are opposite angles, that they're supplementary, so they add to be 180. And then the measure of angle L plus the measure of angle N is also 180, because those are also opposite. All right, so we want to find the measure of angle X. So we can take 180 minus 60 to give us our 120, because we know that the measure of angle X plus the measure of angle Z has to be 120. And then to solve for Y, we can take 180 minus 95 to get that to be 85 degrees. So another short one. Good luck on the homework.